This is how to determine the heat of solution of an ionic salt when you dissolve it in water. A 0.250 mole sample of some unknown lithium salt is dissolved in 315 mils of water in an insulated container at 21.4 degrees Celsius. After the solid dissolves, the temperature of the water is 26.3 degrees Celsius. What is the heat of solution of LiX? And we're given the specific heat of water. Okay, just some background. What we're being asked is LiX, which is a solid, will dissolve in water to give lithium cation and our unknown material anion. And some heat is involved in this. Now, heats of dissolution or heats of solution can either be, solution can either be positive or negative. So let's look at what happened with the water temperature. We go from 21 degrees Celsius to 26 degrees Celsius, so it got hotter. So in our case, this is going to be exothermic, and we expect a negative value. But if the temperature had gone down, don't forget that you could have an endothermic reaction, in which case your heat of solution would be positive. It would require heat energy. Okay, now to the actual problem. The heat involved in dissolving NaX has to be equal to the heat lost or gained when the water changes temperature. So that should be equal to negative ms delta T of the water. Okay, we know we have 315 mils of water, so that's as good as having 315 grams of water. We are given the specific heat of water is 4.18 joules per gram degrees Celsius. And as far as the temperature change, the final temperature is 26.3, right? That's T final. And the initial temperature is 21.4 degrees Celsius. So when we subtract that and multiply it out, we get a value of minus 6451.8 joules. Now, usually we work in kilojoules in chemistry, so that would be minus 6.452 kilojoules. We're not quite done yet, though, because that is for our 0.25 moles of material. So we will take our minus 6.452 kilojoules and divide it by our moles of material that we dissolved, 0.250 moles. And when we finish that math, it is minus 25.8 kilojoules per mole. And that is equal to our delta H of solution. That's not so bad.